I'm grinning. You know why I'm grinning? Because I love implementation videos. I love where I can just sit and dwell in the live interface of Cisco routers for an entire video, and that's what we're going to do here. We're going to walk through the implementation and verification of EIGRP. And we're going to do nothing but sit in the live interface. I've got a live scenario where we're going to walk through setting up a corporate network environment for EIGRP. We'll walk through the configuration basics, adding some default information, and then hit the verification commands. This will lay the foundation of EIGRP and, in my opinion, convey just Cisco's goal with this protocol to make it one of the easiest to configure but most feature-packed protocols that exist on the planet. Well, let's not waste any time. I want to jump straight into this landscape of our corporate network. Now you can see that we have three routers here. Router 2 and router 3 are connected to a shared segment, a bridge segment over here with same switch, 10.1.2.0/24. Now router 2 connects back to the corporate office on a /30, 10.1.24, and router 3 is connecting back 10.1.34, another /30. Now, the backbone router sitting in the corporate network is, of course, reaching to the branch offices, as represented by router 2 and router 3, but also has a bunch of local subnets. You can see them all here as the 172.30.0, 1, 2, and so on. All of these subnets, maybe they're VLANs, maybe they're offices, maybe small little offices on the campus network that are connected via fiber optic cable. We don't know. We just know that we have all of these networks here, and we have to have EIGRP running across this entire backplane. So I want to jump straight into the configuration, starting off with router 2, just to give us a pinpoint. Router 2 is the router in the lower right, or mid-right. Router 2 is going to be our starting point, and a lot of these commands are going to be familiar to you from the CCNA. This is designed to just get our blood flowing as we lay the foundation of EIGRP, and then we'll get into some of the advanced topics. So first off, we need to start the routing process. I'm going to type in, let me back out here and just do a show IP protocols, which if you hit enter shows nothing. This command verifies what routing protocols are running, and we can see that nothing is out there. I'm going to type in router EIGRP followed by an autonomous system number. Now, unlike OSPF, this number must be the same between all routers in our organization that want to exchange routes. Now, a common question I get is, well, if it has to be the same, what's the point of the number? Good question. You can actually get into some advanced routing with EIGRP where you have one router that routes for two totally different autonomous systems. It's pretty rare, but you can start two completely disparate, two separate processes of EIGRP on the same router. Doesn't matter which number you pick as long as they're all the same. I'll use the extremely creative number 1. Now, underneath the routing process, I need to type in my network statements. So what I'll typically do, let me see if this one has an iOS that supports the do command. No, it doesn't, of course. I'm going to use, I have an alias created for show IP interface brief. And I can see all of my interfaces. I see the Ethernet network 10.1.2. You see that right here, 10.1.2. In this case, router 2 is the .2 address. I have the WAN link, and you can see I have some other addresses, but they're shut down. There's some other frame relay links that aren't going anywhere. This is my WAN link that links me back to the backbone office. So I'm going to get back under the router EIGRP and type in network 10.0.0.0. Now that is the, I guess you could say, the easiest way of turning everything on. That is the class full way of enabling EIGRP. Now with that in mind, that's my least favorite way because it's so messy. And that automatically turns on EIGRP for all of my interfaces that start with the number 10. Now, that's great in this case because I do want to run EIGRP everywhere. I want to be able to send, geez. Oh, what's going on? I'm dropping things left and right. Stuff's falling down. See, when you have a desk like mine, sorry, climbing under the desk here because I lost my pen. One bump of the tower sends a whole pile of paper flying. So here we go. I've got my pen. By typing in that one network statement, we actually have hello messages that will be sent out trying to form relationships on that network and that network because they both, of course, start with the number 10. Also, both of those networks will be included in my advertisements. The messy part of this is that if I ever bring up another 10 network, like, say I add an Ethernet interface over here, as soon as I activate that interface and give it an IP address, poof, EIGRP lets everybody know about it, and that may or may not be what I want. For example, you saw in my show IP interface brief, I've got a couple other 10 interfaces that are shut down. Maybe those aren't in use. Those are maintenance lines or backup links that I enable on demand. Now, I'm coming up with examples on the fly here, but the point is maybe I don't want to run EIGRP on those. That's when this command gets a little messy because it runs regardless. I'll show you how to fix that in just a little bit. The other command that's almost a no-brainer to type in on EIGRP is the no auto summary. You may have seen that command before, but by default, EIGRP acts like a class-full routing protocol. Class-full is horrible. You want a classless routing protocol. The way I remember that is this is the only time it's good to be considered classless. Classless routing protocols advertise the subnet mask with their advertisement. And EIGRP is kind of this weird hybrid protocol. It's classless to start off with, but typing in no auto summary will keep it from summarizing the links automatically. For example, let's say that on router 2 right here, this new link that I brought up is 192.168.1.0. And some other router over here, we'll say it's router 5, we'll bring them in the mix, is connected off here to some mystery part of the network, another major corporate office. Well, if you keep auto summary turned on, as soon as router 2 advertises its 10 network across this non 10 network here, it will automatically summarize it back to the classful number. 10.0.0.0/8. So router 5 believes router 2 has everything that starts with the number 10. Now, 10's a big world. I mean, there's a lot of addresses that start with 10. And if something else in this mystery part of the network is using a 10 address, we may very seriously hose some stuff up. So the good news is that simply by typing in this no auto summary command, and you want to do it on all the routers, they all have to be the same, we will turn off this auto summarization, and instead of advertising that big blob, it will actually advertise the specific subnets that exist in our network. So much better. So EIGRP is set up and good to go on router 2. I'm going to back out here and jump over to router 3. Let me just clear off the screen so we can get a fresh slate. Now on router 3, I'm going to go in and, well, I'll do a, let's see if I got the do command on here. Good. If you haven't seen the do command before, oh, it's awesome. It lets us do any show command or any privilege mode command from whatever mode we're in. I'm going to type in do s, which is my alias for show IP interface brief. You can see it's all 10 networks. We've got one in that 10.1.2, which is this switch network back here. But I'm going to type in do show IP protocol, and much to our chagrin, we have no routing protocols running. So I'll type in router EIGRP 1, and I'm going to type in the network command first. Again, I'm going to do it the lazy way, just network 10.0.0.0. Now, I made a special point to say first, because I want you to see that as soon as I type that in, it's going to form neighbor relationships. And notice, suddenly, dual, that's our routing algorithm, says, hey, there's a neighbor change. I've got neighbor 10.1.2.2. Guess who that is? That's our friend router 2 that I just found out on the Ethernet 0/0. So your switch network has formed a new adjacency. That's fantastic. But if we didn't type in no auto summary, no auto is the good shortcut, no auto summary first, watch what happens. I type that in, and wham, the neighbor relationship dies and then reforms because it says, hey, your way of doing summarization, that auto summary, has been reconfigured, so I need to kill the neighbors and bring them back up. Now, if that was a production network, that caused some problems because you just lost your neighbor relationship. So at this point, let's see here. I'm going to type in show IP protocols. Shows that we are running the routing protocols. And remember those K values? There they are. You can see the default K values. That deals with the metric by default. Bandwidth and delay, K1 and K3 is turned on. All the others are turned off. Shows that we have a routing information source, our bud over there, 10.1.1 or 10.1.2.2. We formed a neighbor relationship, and we're routing for network 10, the big deal. Now, if I type in show IP route at this point, we should know about that WAN link that's going on between router 2 and the backbone router over here, because this is not directly connected by default. So that's the only new route that we should learn about from router 2. And sure enough, there it is. Right in our list. We learned about it from router 2. Best way to get there is through the Ethernet 0/0 port. There's our ugly metric, which if you haven't looked at the concepts video, there's a whole formula for that, which I'm not going to ever mention again. And then over here we have the /30 mask, so we know auto summarization's been turned off. We're using variable length subnet masking because we have multiple subnet masks applied to a single network, which is the 10 network. Good, right? So now let's hop over to the backbone router. This router, now I have to admit, I am simulating all of these networks over here just by using loopback interfaces. So I'll do a quick show IP interface brief, and you can see I've got a bunch of loopbacks, which makes our network look a lot bigger than it really is. Now here are the two WAN links that are reaching our neighbor routers. And I want to show you, as I configure EIGRP on this one, I need to type in router, EIGRP, and I'll put 1. And the network command is also very compatible with wildcard masks. Now, if you haven't seen them before, well, you probably have from the CCNA world, but if you haven't seen them, wildcard masks, often called inverse masks, are exactly the opposite of a subnet mask. They dictate what significant bits you want to focus on. Let me give you an example, and then I'll show you how the wildcard bits work. In this case, maybe I'm looking here and I only want to run EIGRP on the highlighted network right here, 10.1.34.x, that one WAN link. I can type in network 10.1.34. Now there's many ways to do it, but right now I'm just going to type in .0 followed by question mark, and you can see right there EIGRP wildcard bits 0.0.0.255. Enter. EIGRP is now running on just this one interface right here on the backbone. So remember, the network command does two things. One, hello messages are going out, so it's trying to form a neighbor relationship. And two, it's going to advertise this network to its buds. So when it's forming another neighbor out here, so when it speaks to router 2 eventually, it's going to say, hey, I know about this network right here. So it will advertise those out. So that's the two functions of the network command. Now, let's talk about those wildcard bits. Notice we formed that neighbor relationship, right? I'm going to kill it. No auto. Turn off that auto summarization. Let it go ahead and reconverge in the background. But let's talk about the wildcard bits. I typed in 10.1.34.0, 0.0.0.255. Now, flyby review of wildcard bits. Wherever you see a 0, that is a bit that says, look at these. As in, look here, I have some interesting stuff. So I see a 0 where it says 10, so I will look at the 10. I see a 0 where there's a 1, so I will look at the 1. I see a 0 where there's a 34, so I will look at the 34. Meaning, I will turn on EIGRP on any interface that starts with 10 as the first octet, 1 as the second octet, and 34 as the third octet. Wherever you see 255s, or to be more specific, wherever you see 1 bits, if you change that over to binary, this means I don't care. I don't care what is in that octet. Meaning, if I'm looking at that interface on the backbone router, does it actually have the IP address 10.1.34.0? Let's look at it. No way. It's got 10.1.34.2. But you know what? Because we put that 255 there, it says I don't care. I don't care that there's a 2 there. You know, and you put 0 there, you have a 2 there. I don't really care. Now we could have written that as network 10.1.34.2 if we were putting in another network statement. This is an alternative, and I could put wildcard bits of 0.0.0.0, which means every single one of those bits is significant. Look at these, 10.1.34.2. I have to have an exact match on that. I love wildcard masks of all zeros, because they let me be so specific. All I need to do is identify the interface. Hey, this guy right here. 10.1.35.4.2, and it says I will run EIGRP on that one interface. Now, last thing I'll mention at this point on the wildcard bits, because I know this is some review from the CCNA world. A lot of people get confused and they think, well, the wildcard bits really influence what you advertise, right? Like if you type it in like this, EIGRP would start advertising 10.1.34 as like a /24, right? Because you put kind of a Class C wildcard mask or inverse mask, if you will. The answer to that is no way. It does not influence in any way what is actually advertised. If I type in this wildcard mask, 0.0.0.255, the backbone router looks at this interface and says, oh, I have 10.1.34.0/30, meaning I will advertise that /30 mask. It doesn't care that I put in a /24 wildcard mask. All the network command does, all this command does right here, is tell it which interfaces to send hello messages on and what networks to advertise. It does not dictate how to advertise the network. I guess that's a better way of saying it, right? So even though I type it in as 10.1.34.2 with all zeros there, it's not going to actually advertise 10.1.34.2. It's going to advertise 10.1.34.0 255 255 255 252, which is what a /30 mask is. Good. So that is the network command and our way of using the wildcard bits in combination with that. Let me just, with one fell swoop, turn on the networks for all the rest. Let's get ugly here, right? I'm going to type in network. No, you know what? I'm not going to do that. What I was going to do, just so you know, I was going to type in network 0000000 and then put 255 255 255. What does that do? It says, I will turn on EIGRP on any interface that starts with 0000, and then it says, I don't care, I don't care, I don't care, I don't care. So it's saying I'm running EIGRP on anything. I don't care. If it has an IP address, I don't care. But the reason I'm backing away from that is because I'm seeing right here some interfaces I'm not going to use, like this Ethernet one right here. I don't want to advertise that because, well, that'll cause problems. So I'm going to type in network 172.30.0.0 wildcard mask 00255.255. That's, you know, whoosh, one swoop, and I've started advertising all these networks to the neighbors. And I want to turn it on for the other WAN link. So I'm going to type in network and just paste that one in there with a wildcard mask of all zeros. That, my friends, is my favorite way right there. So at that point, it should form neighbors, sure enough, on both of those connections. So let's bring this home. We've got the show IP protocols, which verifies EIGRP is running, shows what networks it's advertising, and it shows even what wildcard mask I use when I type them in there. Remember, that does not dictate what is advertised, as in it's not advertising those masks. It's just advertising, it's just dictating what interfaces, what networks on the interfaces are being advertised. Whew, that's a confusing thing, huh? It also mentions right here the routing information sources. These are the neighbors I've formed, but that is not my preferred way of finding my neighbors. I like typing in show IP EIGRP neighbors. Guys, if you're troubleshooting, that right there is your #1 verification command. Show IP EIGRP neighbors will show you the neighbors that you formed. Now, I just want to hit some of the flyby high points. First off, this H. If you can find out what H stands for, you you are a good person, because I don't think it's documented anywhere on Cisco's website. A lot of people think, oh, well, doesn't that mean hop count? Now you're thinking rip. This is just the order that it learned the neighbors in. It just happened to learn this neighbor first and form that first, neighbor 0, and this was the second neighbor, neighbor 1. The next one would be neighbor 2. Shows what interfaces it's communicating to them on. The hold down timer, meaning it's kind of morbid, but that says how long until this neighbor is dead. So if I don't hear from this neighbor in 15 seconds, or sorry, here in 14 seconds and 13 seconds, I will consider that neighbor dead. Now, as I hit the up arrow and do this again and again, you will see those timers change all the time, because hello messages are being sent out, in this case, once every 5 seconds. So if you miss 3 hello messages, thus 15 seconds here, you will be considered dead. So hopefully we never go below 10, which means we never miss a single hello message. This is how long the neighbor's been up. This is known as the source round trip timer. And we're starting to get into stuff that doesn't really matter here. But this is how long it takes to get to the neighbor and back. So I can see I have one very fast neighbor and one very slow neighbor. That's how it figures out how often it should send a retransmission should a packet be dropped. Sequence number, you know, how long, what sequence the database is, how many packets are sitting in queue waiting for the neighbor, you know, stuff that gets too deep that we don't really need. But the point is that if you're not seeing routes with that show IP route command, first place I always go is that show IP EIGRP neighbors. Now hold on a second. Whoa. Oh, wait a sec. Take a look here. Are we missing something from this routing table? Yes, we are. There is a network behind router 2 and router 3, 10.1.2.0/24. Do we see that with a D by it? No, because I goofed up. You can see right here, there is 10.1.2. I accidentally have that assigned to my Ethernet 0 interface. This was back when I actually was thinking backbone router would be over here on this side of the network, and I messed up and forgot to remove the IP address. So let's fix that. Ethernet 0/0, no IP address, because directly connected interfaces are always more preferred than a learned route. I might as well just shut that bad boy down while I'm here. These are always more preferred because the administrative distance is 0, meaning EIGRP routes will never be accepted. Now let's try that again. Show IP route, and there's our buddy, our D. The route has been learned. Notice it's load balancing because the metrics as of right now are exactly equal. So it is load balancing across those routes evenly, equal cost load balancing. Now, last command I'll do, and then we'll do some tweaking, is the show IP EIGRP topology. Now, remember, we saw this, I think I showed this to you in the concepts video when I was trying to explain, yes, I did, the active and passive routes. Remember, passive are good, the successors and feasible successors. Now, I want you to see right now, look at this. This is from the backbone router's perspective, and we have 2 successors to the 10.1.2, which makes sense. That's the ones that we're load balancing on. Because one of the things we didn't do was accurately identify the interfaces. Because it just so happens that the link going to router 2 is 1.544 megabits per second. However, this other link over here, well, this one, you know, due to the budget cuts, is just 1.0 megabits per second. Okay, so in that case, what I need to do is jump under the interfaces, and I'll just do a show interface serial 0 that I don't remember. So let me do a quick show IP interface brief. Show interface serial 0/0.2. Let's check out one of them. And you can see it thinks the bandwidth is a full T1 line. Now for the router 2 connection, that's accurate. But for the router 3 connection, not so accurate. Let's get under interface serial 0/0.3. I'll type in bandwidth 1000 because this is in kilobits per second, which drops it down to a meg. Immediately, I can see that reflected in the bandwidth here, and immediately you will see in the show IP route oh, I said immediately, didn't I? Almost immediately. It was like if I would have said immediately 3 times fast, it would have happened. You can see by the time I did that command a second time, the second load balance route has been removed. The dual algorithm reran. But look again, when we do the show IP EIGRP topology, if I can find that in my history, notice it's still there. This is the one unique feature that EIGRP has that no other routing protocol has. It keeps backup routes. So even though it shows now one successor, one primary route going that direction, it still remembers the backup route. And in case of a failure of the primary, it can immediately switch over to that backup. Groovy. So we've got the base EIGRP configured. Now let's go ahead and lace in a little default routing. Let's imagine that the backbone router is connected to the internet. So this corporate network, you know, we've got the building, of course, and then we've got maybe some T3 massive pipe going off to the internet cloud. Now, the backbone router wants to tell router 2 and router 3 that it is the gateway to the internet. If you want to get to the internet or some destination you don't know about, use me. With EIGRP, there's a few ways. Actually, many ways you can do this. It all depends on your preference. The first way is my least favorite, but you'll find it in Cisco docs all over the place. It's known as the IP default network command. I the more I do this command, the more I hate it. I have to admit that. I don't like the IP default network command, but before I digress on why I don't like it, let me talk about what it is. If I wanted to advertise a default route, let's say on the backbone router here, to one of my other devices. So, I want router 2 and router 3 to use the backbone as its default router route. I could just pick one of these networks. Let's say the 10.30.0.1. Now, I want you to imagine with me that that is the network right here. That this is the 172.30.0.1, or I'll put 0.0 network up here. So that is the link between us and the ISP. Well, what I could do is I could go into global config mode and I could type in IP default network 172.30.0.0 and hit the enter key. Now what that will magically do, I'll go ahead and go back here and type in show IP route, is it will flag one of those routes you can see right here as the default routes. You can see the connected, it suddenly has this little star, which if you look up at the key, let's see right there, star, candidate default. Now the first thing I want to mention is that this does absolutely nothing for the backbone router. You can see that as of right now, the gateway of last resort is not set. So it's saying, I do not know a default gateway. So the backbone can't get to the internet right now. But let's go check out the backbone's friends. I'll check out router 2 and do a show IP route. Now, what's happened over here on router 2 is suddenly, out of the blue, this route gets flagged as a default. And look at this. Gateway of last resort is now this IP address to the network 172.30.0.0. Weird. Now, this does work, meaning that if I were to ping, ping 4.2.2.2, which is a DNS server on the internet. Now, you can see, well, let me do this. I'll type in trace route 4.2.2.2, because this, the backbone router doesn't really have an internet connection. You can see that what it does is it sends it to the default gateway, even though it doesn't have a route for it here in the routing table. Now that's weird to me because I don't know, because it's weird. If you look at this, it's just like this mystical network. It's flagged as the default. Now that command is very handy if you just want a quick default. But the reason I don't like it and the reason I don't use it in the production environment is because it's just confusing. I guess if you want job security, that's a great way to go about it. But other administrators are going to look at this and just be like, well, why that one? What's the star for? I don't get it. It doesn't make much sense. And we're used to default routes being IP route 0000, right? So also, let me show you a byproduct. I'm just going to go to the backbone router and do a quick show run, because anytime you use that command, the IP default network command, let me scroll down here. Right there, IP default network. You see it? We typed in that command. The router, oh, they fixed it. Did they? Yes, they fixed it. Well, let me say this. On older iOS versions, and I should say around the 12.2 range, when you use that command, it will magically generate a static route to 172.30. Now, it makes no sense, and that's why I'm saying they fixed it, because it makes no sense that the static route is there. If I were to take you to an older router and do that command, you'd just see this static route out of nowhere saying IP route 172.30.0.0. Now, the reason I say it makes no sense that the route is there is because you have a connected interface to that. So it's never going to use the static route, but that's just a byproduct on, I'll say, older routers now of using the IP default network. So I think I've said enough on that. I don't like it. Don't use it. The best way to go about a default route, in my opinion, with EIGRP is to do this. IP route 0000. 0000, right? This is a static default route. It's how we're used to putting in default routes on Cisco routers. And then either do the exit interface, in this case I'll put loopback 0, or you can do the next hop IP address, which will say this is where I go to get to my internet service provider. Then I go into router EIGRP 1 and type in network 0000, which just says, go ahead and advertise the default route. And now, when I do a show IP route on the backbone router, I can see that, aha, I've got a default route now. You can see gateway of last resort is set. And if I actually had an internet connection tied into this router, it would be able to reach out to the internet. That's a standard default route. So it not only affects the backbone router, but look here. I hop over to router 3. Let's hit that guy and do a show IP route on this side. And voila, we've got a beautiful default route, which people are used to seeing, 0000. That's the standard default route with a little star by it. And I don't have to put a default route on router 2 and router 3. That is by far my favorite way of doing a default route in EIGRP. The final way, which I'm not going to show you right now because it's part of a topic later on, is by doing redistribution. I can actually redistribute that static route into the EIGRP process. But in my opinion, not as efficient as using the network command, and it's more prone to problems. So as promised, I've gone through the base configuration of EIGRP, talked about getting default network information or default route information spliced in there. And I have been doing the verification commands all along. The show IP route, show IP EIGRP neighbors, show IP EIGRP topology. There's only one show command I haven't shown you yet, and that is the show IP EIGRP traffic. This is just a quick show command that will give you a number of hellos that you've sent, updates, queries, all of the information about the messages that are being exchanged. Now, we did get into what these messages are, but we haven't gotten into things like stuck and active. That's going to be when we get into the advanced configuration in the upcoming video. But those 4 show commands are all you really need to check and make sure EIGRP is up and active. So I want to go ahead and draw the line in the sand here on this video, because we've really hit the core pieces of EIGRP, the configuration basics, where we walk through and just set it up with the network command. In the newer routers, and again, I'll preface this, on the newer routers, it does allow you to do the wildcard masks. On older routers, you don't have that ability to do the wildcard mask. So upgrade your routers is the point. We looked at advertising default information using the default network command, or just by typing in network 0000 and sending your default route along its way. The verification commands we took one by one and walked through those, and we'll only get more advanced as we get into the upcoming video on EIGRP. But the point I really want to convey as we wrap things up here is EIGRP is awesome in that it's so easy. If only it weren't proprietary, it would be the best routing protocol in the world. It's a piece of cake to configure, and you've seen the core of setting this thing up as we've walked through this video. So I hope this has been informative for you, and I'd like to thank you for viewing.